Good day, guys. All right, so today I want to talk about chapter 4, 4.1, types of forces and how to draw the body diagram, right? So let's look in this part, which talks about the types of forces that we cover in the program, right? So there are four types of forces. The first one being gravitational force. So gravitational force is force that is experienced by a body if that body is in a gravitational field. We generally will call this to be weight, right? So when we say how weighty something is, it's how much it interacts with the gravitational field. So weight, right? The second one is what we call frictional force. So frictional force is when two rough surfaces that they're in contact and they are moving relatively to each other. So we visualize this F. And just a note that frictional force in the direction opposite to the direction of motion. Okay, and then the third one is normal force. So say your body is in contact with a stable object, then you will have normal force exerted on the body away from the stable object, right? Normal and away from the stable object. We will use N to symbolize this, right? Then the last one will be tensional. And tensional force is force that is transmitted axially or along a massless, one-dimensional continuous element. What this refers to, in fact, strings or cables. They're one-dimensional, and generally we will assume them to be massless. I will use Ft to symbolize tensional force, right? So let's look at how we can use those four forces and draw free body diagrams. Okay? So there are generally three rules that I go by. The first one is always start with a dot, and this dot will be located at the center of gravity of the body. So say you have a box, right? You have a box. Then you will draw the dot at the center of gravity. Okay. Now, second one is you should be able to recognize types of forces present. So again, let's just cover it again. Let's just remind ourselves that there are four types that we cover: work, normal force, frictional force, and tensional force. Right? Okay. So if that thing, that body, is influenced by gravity or in the gravitational field, then we will have weight. If that body is in contact with a stable surface, then we will have normal force. If the object is like and the two surfaces are rough, they're moving together, then we will have frictional force. A string attached to the body, then have tensional force. Okay. So and then the third one will be the fact that you always draw arrow forces arrows be away from the dot, never towards the dot, always away. Okay. Those are the general three rules that you can use to find yourself how to draw body diagrams. In the next slide, we'll be covering um, examples, right? Okay. So let's go through the first example. A book is at rest on a tabletop. Have a tabletop, table, book. Sketch body diagram of the book. So the body diagram, you always start with dot. Then second step is down types of forces that you have learned. F, F, T. No string is present, so there will not be tensional force. The book is at rest, so it's not moving relative to the tabletop. So there's no frictional force. It is in contact with the stable surface, so you will have normal force. And then we assume that the book and the tabletop is on Earth and is influenced by gravity. Earth, therefore weight. Okay, so that's how you draw the free body diagram for this particular. So example 2, an egg is dropped from the roof of the building to the ground. Neglecting air resistance, thus neglecting the friction between the egg and the air, sketch the free body diagram of the egg as it's falling. All right. So at this point, I would like you to pause the video, get a pen and pencil, pen or paper, sorry, and then try to sketch it out, and then compare your solution to mine. Right? 3, 1. Let's discuss this. So let's have an egg. Let's have an egg drop from the roof of the building to the ground. Okay, it says free body diagram, so we always start with a dot. Okay, write down W and FF FT. There's no string, so there's no tensional force. We are neglecting air resistance. There's no frictional force. The egg is not in contact with any stable surface. There's no normal force. But the egg is falling, so it is interacting with gravity. Have weight. Draw an arrow represent force or weight. That's it. That free body diagram. Okay. Now let's look at the next example. Example 3. A college student rests a backpack upon his shoulder. The backpack is suspended motionless by one strap. So strap from one shoulder. Sketch the free body diagram of the backpack. So free body diagram, draw a dot. Okay. And we write down W, N, F, 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 T. Okay. Now there is a string this time, so we do have FT. Draw this along the string. The body is not in contact or moving relative to any other surface. So motionless, so there is no frictional force. There is no normal force because contact with any stable surface, but there is a weight. W, F, T. That is a free body diagram. Okay. Example 4. Consider a metal block at rest on an inclined plane. Inclined plane. Here's my metal block. Sketch the free body diagram. Dot. Then write down W and F. There's no string, no tensional force. It's not moving. There's no frictional force. There is a normal force, and it is normal to the surface. You extend this back. And then you have weight goes directly down, W. And that concludes our free body diagram for this particular case. Okay, so there's a little bit of progression in the next example where the metal block is sliding down the inclined plane. Let's draw the inclined plane again. This time the metal block that direction, B, cos theta. Sliding down, sketch the free body diagram. Again, we always start with a dot. We'll have W and F. There's no strings or cable, so we won't have tensional force. It is moving, right? So we do have frictional force. It's going to be against the direction of motion. Against direction of motion. It is in contact with a stable surface, so we do have normal force. And then we have weight. Action, gravity. Okay? Alright. That concludes 5 examples that we've covered on how to draw free well as types of forces that we are expected to know in relation metric diagram, right? So that is at the end of this video. The next video I'll be discussing Newton's laws of motion, right? So I'll see you the next video. Thank you very much.